This video is going to be over piping drawings. So on slide 1, we're talking about pipings made of the following materials: aluminum, brass, clay, concrete, sometimes made with both aggregates and in combination with other materials. It's also made of copper, glass, iron, lead, plastic, rubber, wood, and other materials or combinations thereof. Note that cast iron, steel, wrought iron, brass, copper, and plastic are the most commonly used for transporting water, steam, oil, or gases. If you take a look at the picture on the first drawing, you can see a massive amount of piping network in an industry. Pipe is also used for structural elements such as columns and handrails. Building plans for industrial plants, commercial buildings, and residents all use pipe diagrams to describe the distribution path of the gases and liquids these buildings require. Special schematic symbols simplify each type of pipe connection. Pipe symbol templates are also available to simplify the process of hand sketching. In addition, CAD libraries provide piping symbols for quick insert into the drawing. Now, the objectives for the class are the following: identify cast brass, copper, and thermoplastic pipe and tube fittings. Draw and label common pipes using the ANSI standards and the ASME design standards. Drawings can be made up of two types of symbols. They can be drawn in pictorial view, which is a multi-view, and they're drawn using the schematic symbols for valves and to identify flow direction. Now, what we're going to talk about next is the standard of the symbols. So in this slide, we're talking about the symbols that have been created to represent various types of fittings and valves. Down here, we have T connections, we have bells, and we have elbows. We have valves. Elbows can be 45s, they can be long elbows, they can be short, they can have 45 degrees, 22 degrees, they can be T's, various symbols. And these are different types of symbology that is used in a piping diagram. Now, the different types of diagrams there are two types of piping diagrams. There's single line showing where the center of the line of the pipe is, and there's double line drawings where you typically have two lines representing the diameter of the pipe. Now, in a complex piping system, it is desirable to use double line or multi-view drawings drawn accurately to scale, whereas the single line drawings are not always drawn to scale. Either of these drawings can be used to create orthographic drawings. Now, there are types of drawings, and you can use an axiometric drawing to use to create pipe drawings, or you can use diametric diagrams, orthographic projections, and developed drawings. Developed drawings are used to create plans that are shown entirely on a single plane. That means the vertical pipes have to be revolved in the horizontal plane, and the horizontal pipes would have to be revolved into the vertical plane. So you're having the drawing shown only on one plane. Now, when we're talking about dimensioning piping diagrams, dimensioning for pipe diagrams should show the distance from the center to center and the center to the end of fittings and valves. Break lines may be used for long pipe lengths. Allowance of pipe lengths for fittings and valves must be made in the bill of materials. See figure 21.1, 21.2, 21.3, all the way to 21.7 for illustrations in your book. Now, they also gives the lengths of the runs when they're straight, and they also show the pipe size of each object. When you're talking about steel and wrought iron pipes, you're talking about pipes that are used for steam, water, oil, and gas products. Pressure and temperature control the pipe weight and thickness of the pipe. In ANSI, ANSI has developed 10 different schedules for these types of pipes. In your book, you can see Appendix 37 for the various pipe sizes. Now, pipes may be welded or seamless. Welded pipes are available in schedule of 40 to 80. Steel pipe is available in black pipe or galvanized pipe. Black pipe is used for gas products, and galvanized pipes are used for water distribution. Remember, black pipe is used for the distribution of natural gases. When you're talking about cast iron, you're talking about pipes that are labeled as CI, and these are typically used for water, gas, and soil. Pipes for water and gas is usually available in diameter of 3 inches to 60 inches and in standard lengths of 12 feet. Now, cast iron is put together by joints. You can have a bell and spigot joint, a flange joint, or a mechanical joint. When you're working with the bell and spigot, you're typically connecting a water pipe or gas pipes. You don't usually use a mechanical joint to connect water pipes. Now, when you're talking about soil pipes, you're talking about 3 inches to 15-inch diameters and a standard length of 5 feet. Designers have to consider the internal pressure and the external load of these types of pipes in addition. Cast iron is brittle and when settling in the earth may cause the pipe to crack and break. Now, see figures 21.8 and 21.9 in your book for illustrations, and Appendix 38 for various classes and pressure ratings of these pipes. Also note in this figure here, when you're talking about this pipe, notice it's a half section. They're showing you a hatched area showing what the bell and the spigot looks like. The bell is this part of it, and the spigot is this part of it. Flanged means there is 2 pieces bolted together, similar to the mechanical joint. Seamless and brass and copper pipe are used for your plumbing type fittings for vents and drains. So brass and copper pipe is available in standard and extra strong pipe dimensions. Brass and copper is typically used in the plumbing industry. Brass pipe is generally known as red brass pipe. Also, brass pipe and copper pipe should be joined with fittings of copper-based alloy to provide and prevent corrosion. See figure 21.9 in the book for illustrations and examples of this. Now, in this slide we have, I'm showing you both the screwed and the flange type fittings. These are the screwed fittings. Flange would be something that has a flange on the outside edges where they're being bolted together. Copper tubing is used in non-ferrous construction. It's suitable for typically plumbing and heating work. Oops, go back, sorry. Now, copper tubing is typically in sizes of 2 inch and below. It is suitable for a process of plumbing and heating systems. Copper tubing is made of hard temper and soft temper tubing. Hard temper tubing is much stiffer than soft tubing and is used when rigidity is desired. Note, copper tubing joints are made with flared or soldered joints. Soldered joints are usually known as capillary joints because the molten of the solder is drawn into space by a capillary action. See figure 21.10 and 21.11 for examples of this. Excuse me. Also, most common way of connecting copper tubing is to use threaded pipe, and the most common way for the most common way of connecting copper tubing to threaded pipe is using adapters. The next type of pipe we're going to talk about is plastic and specialty pipes. In this slide, you're seeing all various types of pipe. When we're talking about plastic pipe, we're talking about tubing that is made of other materials such as PVC, HDPE, CPVC, and what it's used for. PVC is polyvinyl chloride, CPVC is chlorinated polyvinyl chloride, and HDPE is high-density polyethylene pipe. Now, these pipes range in various sizes, and the pipes are used for different products. Now, also note, these are all PVC pipes, and this is high-density polyethylene pipe. Notice that these are in different colors. You got a blue pipe, a pink pipe, and a green pipe. The blue pipe is typically, for construction standards, is noted for water. Purple is for reuse or reclaim water, and green is for sanitary sewer, usually force mains. Notice the high-density polyethylene pipe has a blue stripe. That means typically high-density polyethylene pipe is always black, and the color that is of the line on there goes with the type of property that pipe is being used for. There are various standards. The PVC and the CPVC pipe range in 1/2 inch to 4 inches in size. And also the CPVC pipe is similar to the PVC pipe, but the CPVC has a much higher temperature rating. And the application of these materials vary according to their physical properties and temperature. Now, when we're talking about pipe fittings, we're talking about fittings that are used to join lengths of pipe and for pipe to change direction. So if I had a pipe coming this direction, I use a 90-degree elbow and it turns sideways. The T-fitting is you have a standard straight line pipe and another pipe coming in at a 90-degree angle. The cross is used for bringing in 4 different directions. You have lateral pipes. You have long radiuses, you have 45 elbows. You also have a 22.5 and an 11.25 elbows. These pipes provide branch connections at different angles to determine and affect different directions and sizes. You could actually have a bigger pipe coming in, a smaller pipe coming in, and a bigger pipe coming out. For example, you have a 12-inch coming in and maybe a 16-inch coming out. Fittings are available with threads. They can be welded together, soldered together, or they could have flare ends. If you see figure 21.9, 21.11, 13, 14, and 15 in your book, you can see the different types of fittings. You can also see Appendix 39 through 44 for cast iron and flanged fittings. All right. These are the various types of fittings. So you can see in this one has a 1.5 inch by 3.25. So a 1/2 inch comes in, or a 1.5 inch comes in, and a 3/4 also comes in or goes out, however you want to look at this. Okay. So you can have a 1 inch by 1 inch. So this is 1 inch, and I'm talking about the cross. You could have a 1 inch going this way and 1/2 inches going this direction. The next thing we're going to talk about the different types of joints. Joints can be connected together to fittings and valves, and they can either be screwed joints, which is this picture here, flange joints, which is this picture here. These are also screwed joints. And you can also have welded or soldered joints. Now, plastic pipes may be screwed together or fastened with slip joints or a solvent with compression fittings. The threads of the API, American Petroleum Institute, differ somewhat from the American National Standard pipe threads. Now, the threaded joints can be made up tightly by simply screwing the cleaned threads together. However, it is common practice to use pipe compound as a lubricant that the threads as to lubricate the threads, and this enables them to screw together more tightly. This compound also serves to seal irregularities, providing a tighter joint. Flange joints are made by bolting 2 flanges together here with a resilient gasket between them and the flange faces. The flanges may be attached using a screwed joint or by welding lapping the pipe, or by being cast integrally with a pipe fitting or an appliance. Now you can see different types of joints, either a socket weld or a butt weld, in figure 21.13, 21.16, and 21.17. You can also see Appendix 37, Appendix 42, and Appendix 45 for cast iron. Now, another thing when you're doing piping diagrams, you're always going to have some types of valves. Valves are used to stop or regulate the flow of fluid in a pipe, and the different types of valves include globe valves, check valves, gate valves, and solenoid or actuating valves. This picture here is a ball valve. You can also have, these are ball valves where you can, when you turn the handle, the ball rotates and stops the flow. These are gate valves. Now, I also have, you can take a look on page 759 to see the different types of valves and their standards. It gives a distinction of the different parts of a valve. Now you have a ball valve, a butterfly valve, and you can see how it swings on a stem here in this picture. A check valve, gate valves, globe valves, and Y strainers. These valves can be up to 36 inch in diameter. The most common types of valves are going to be your gate valves, globe valves, and check valves. Other types are pressure-reducing valves or safety valves, which allow to maintain a desired low pressure on a downstream side of a valve to prevent undesirable backflow into a system. All commercial development has to have a backflow preventer, and in the backflow preventer they have some type of check valve that allows you to stop flow from exiting or entering the site, depending on what you're using the valve for. Now, the globe valve has approximately a spherical body with a seating surface that is either right or acutely or at an acute angle to the center line of the pipe. Now, excuse me, check valves are used to limit the fluid flow in only one direction. So a check valve only allows the flow to go out and not to come back in. You can have a swing check valve that it uses a disc that can be hinged to swing partially out into the stream. You have lift check valves that use a disc that guides so that it rises from the vertical of the seat. Again, on page 759, you can see the breakdown of the different parts of the valves. You can see the globe valve, the swing valve, and the check valve on that page. The gate valve on that page. Gate valves have a full-size straightaway opening that offers small resistance to flow of fluid, and these valves are used only on low pressure and low temperature surfaces. See figure 2118 and 2119 for examples of these valves. Last but not least, when you're talking about valves, or you're talking about piping in general, the American National Standard Code for Pressure Piping, ANSI, the American National Standard Code covers information on safety and recommended practices for the various types of pipe used in the industry. That's it for the presentation. You'll be doing homework, and if you listen to this video closely, then you'll find the answers in the homework in this video, and you can check out the notes also posted. All right? See you in class next week. Thanks. Bye.